So this is what we understood in the last session, friends, like Ohm's law. We understood V is equal to IR, and I said that if you make the I is equal to it becomes I is equal to V upon R. So if you increase the value of the resistance, right, current get decreased, and that's how we understood, right, different analogy. And finally we did a calculation here, and in this circuit our objective was to protect this device which is called an LED, right? So I said that if you increase the value of the resistance, probably what will happen is the current get decreased, and as the current get decreased, it has an impact on the illumination of the LED, right? That I will show you practically today also. So this is the circuit that we have looked at last session, right? Now there is a very important circuit that today I am going to introduce to all of you, and that circuit is called a voltage divider, right? This is a very useful circuit that we're gonna use throughout the semester in a different laboratories, where we make a different circuits for different IoT small demo applications and small projects, right? Even in the future when you are working on some projects related to IoT, probably this is the voltage divider circuit is a great help to all of you. So please let us focus on this. So basically a voltage divider is a simple circuit which turns a large voltage into a smaller one. This is very important. So if I want to divide the large voltage, right, into a smaller one, I have to go for a voltage divider, as name suggests, using just two series resistors. See, you already know that you can connect the resistors in the series or in the parallel, and you know the formula. If I connect the two resistors in the series, resistance get added. If I connect them in the parallel, you know already the formula, right? So using just two series resistors and an input voltage, we can create an output voltage that is a fraction of the input. And what would be that fraction? It depends on the value of the resistance that you will select, right? So voltage dividers are one of the most fundamental circuit in electronics. This is very important for you, right? It's a most fundamental circuit. There are two important parts to the voltage divider: the circuit and the equation. So let's try to look at that circuit and the equation. So what is that circuit? A voltage divider involves applying a voltage source across a series of two resistors. Here you can see, right? So this is a voltage source, V in, right? And this symbol indicates the ground. So another terminal is connected to the ground, right? And we have a two resistor in the series, R1 and R2, and then we are getting a voltage across this. So what we are getting actually is we are getting a voltage across actually the R2, right? Because we are measuring the output voltage between the one terminal of R2 and the ground terminal, and another terminal of the R2 is connected to the ground. That means I am measuring the voltage across the R2. Please understand, a voltage divider involves applying a voltage source across a series of two resistors. You may see it drawn a few different ways, but they should always essentially be the same circuit. So here the voltage divider circuit has been represented in different way, right? Four different ways are there, but all represent the same thing. You can look at the another way how you can draw the circuit. So here you have a V input represented like this in form of battery. This is the positive terminal, this is the negative terminal, and again this negative terminal. So when I say ground, it's basically a negative terminal, right? So you are again measuring the V out across the R2, right? Similarly, this is another way how we have drawn the circuit. Here you have a V input, again the R2 is connected to the ground, and you are again measuring the output voltage across the R2, and this is another way. So this battery here is replaced by just a plus and minus symbol, and again the circuit can be drawn like this, and here it has been clearly represented that we are measuring the V out across the R2, right? So example of the voltage divider schematics, right? These are the different examples. We will call the resistor closest to the, this is very important, we will call the resistor closest to the input voltage R1. So the one which is near to V input, we call it R1, and the resistor closest to ground, the one which is nearest to the ground, we call it the R2. The voltage drop across R2 is called V out, right? So we are measuring the voltage across the R2, which we call V out. That is the divided voltage our circuit exists to make, right? So from V input, let's say V input is a bit high value and you are looking for a smaller value for a specific device, then you can apply that V out to that device, which is going to be the smaller one. How it will work, let me show you that, right? So let's look at an example, right? So voltage divider equation assume that you know three values of the above circuit. The input voltage, this is the assumption, you know you have a value of input voltage and both the resistor value, that is R1 and R2. Given those values, we can use this equation to find the output voltage, that is V out. So what is the formula? This is very important formula that you must remember. V out, that means this is V out in the previous circuit like this. V out is equal to V in into, see we are measuring the voltage across which resistor? R2. Right, so it is R2 upon R1 plus R2. It is R2 upon R1 plus R2. Right, because we are measuring across the R2. Right, so V out is equal to V in into R2 upon R1 plus R2. This equation states that the output voltage is directly proportional to the input voltage, that is V in, and the ratio of R1 and R2, right? So here as we are measuring across the R2, so you are taking R2 upon R1 plus R2 and that's going to be the V out. So let's say in one numerical it has been given that, I wish all of you to have a pen and paper and do this calculation. Let's say as we said that we have assumed that we know these three values. So what is the V in? Let's say it has been given as a 5 volt. It has been given as a 5 volt, right? And what is the value of R1? Let's say it's a 1 kilo ohm. R1 is 1 kilo ohm. And R2 is 2 kilo ohm. Right? R2 is given in this circuit as a 2 kilo ohm. I wish all of you to draw this circuit and you need to do the calculation of the V out, right? Then what could be the V out? So it's a 5 volt into R2 is 2 kilo ohm divided by 1 plus 2, and that is nothing but 3. So 5 into 2 by 3. Right, so that's nothing but 10 by 3, and when you know, when you do 10 by 3, exactly what you get V out is actually 3.3 volt. So please understand what this voltage divider circuit has done. By just connecting the two resistors in the series, we are able to convert this 5 volt into 3.3 volt. Right, you can ask me a question, why this is the requirement. For example, let's say I have an Arduino board and I'm giving some voltage, and let's say I have a 5 volt available from example, for example, from Arduino board. It could be different, but just to give you an example, and I wish that at a specific part of the circuit I want to, I cannot give 5 volt as it is, otherwise that device or that component may burn out. So what I want is, I want to reduce the voltage level. In order to reduce the voltage level, you can use this voltage divider circuit. Now the question arises, how should I decide the value of R1 and R2? That depends what kind of output voltage you want, right? So based on that, you can make a voltage divider circuit like this. So I hope it is clear to all of you. What is the use of the voltage divider circuit? To divide the input voltage into smaller, to get the smaller voltage out of what is available. And how to make a voltage divider circuit? By connecting the two resistors in the series. And what is the formula? V out is V in into R2 upon R1 plus R2. Why R2 is in numerator? Because I am measuring the voltage across that. This is the resistor which is near to the ground. This is the resistor which is near to the ground, and this is your ground, right? Fine. So any question till now, boys and girls, then let me know. I can take up if you have any doubt. Right, so I have already introduced to you the circuit which is called a Tinkercad, right? A website which is called a Tinkercad, and I hope all of you are aware of that Tinkercad, right? So if you are not, what you can do is go to the home page of the Tinkercad, and it will ask you for a, it will ask you for a username and the password. So all of you, what you need to do is you need to do the login, right? Once you do the login, and you will reach to the home page of that, right? Once you have a home page, you will get like this. I hope you are able to see my screen. Hello, my browser is visible, right? Okay, fine. So, how many of you have heard this Tinkercad before I said here? I think I have introduced the Tinkercad, right? So I request all of you to note down this website, tinkercad.com, and create your own login after this session. Now, what I want to do is let me, you will get multiple options like 3D design once you go to the home page. Then you have to click on the left hand side here at the circuit. Once you click that, you will get an option here, create a new circuit. So I'm clicking here, create a new circuit. Right. So once I do that, create a new circuit, right, you can see here, you will get the different options here on the right hand side, right. What is written here, friends, is the components. So for example, what I can do is I can look at what are the basics, what are the all, right, and there is some starters. In starters, what they have given is the basics, Arduino, microbit, circuits, assemblies, and all. Right, so even in the components, if I click on the all, probably you can see here the list which is coming in front of you, like general, where I have a resistor, capacitor, polarized capacitor, diode, right, then the an inductor, then I have some push button, potentiometer. What is potentiometer, by the way? I have already explained to you, right? It's a variable resistor that you can think of. Right, so you have a different devices, like different sensors are there. For example, professor has already covered this ultrasonic sensor, right, PIR sensor is there, temperature sensor is there, gas sensor is there, right, some actuators you can see, for example LED, right, a light bulb is given to you, and lot of things available like DC motor, right. You can see the different devices available, lot of power sources available to you like battery, and even the breadboard is available, right. So for example, let's say I want this breadboard, right. What I need to do is I need to drag and drop, right. It's a very simple. So once you do a drag and drop, see the breadboard is here, and you can see when I click here, you can see all I will see is the green line in that row. That means all the terminals are internally connected. Similarly, when I click here, you can see all the entire row is connected. Here entire column is connected, you can see, right. So this is how you can get the different components. Now what we want to do is, I want to show, let's say, the Ohms law, right. I want to show you the Ohms law, right. What Ohms law says, when I increase the value of resistance, my current value will get decreased. If I increase the value of resistance, my current value has to get decreased, right. So what I will do here is, let me go to the basic here in the starter, and see you are getting some ready-made circuit available to you, right. So for example, let's say there is written LED switch. I am directly doing drag and drop on that, right. If I do that, I will get the circuit here. I hope you are able to see that circuit, right. And you can see, let me bit zoom if I can. Okay, I hope you are able to see my circuit, right. And in the circuit, it has an LED, it has a resistance, it has a switch, and there is a battery, right. And it's a coin battery of 3 volt, right. Generally this coin battery we will use in the wristwatch and other smaller devices, maybe toys also, right. So it's a 3 volt coin battery is there. It's a plus terminal. So I have connected the positive terminal, that is an anode of the LED, via resistor. Why resistor we have put up? If we don't put up this resistor, probably it will get more current, and so it will burn out. That is the objective. So what I want to do is, I want to control the amount of current that is passing through this LED. For example, if I click on this LED, when I click on this LED, I am getting some options here. You can see here, right. I can change the color also. For example, I have an option like green, yellow, orange, blue, red, or white. Even I can play around white, right. This is what. And then if you click on this resistor, right, you are getting the value of resistance to be set. So at present it is 220 ohm, right? 220 ohm. And you can change this value also, and you can change the unit also. For example, from 220 ohm I can make it 220 kilo ohm. And you can see here, as I changing this unit from ohm to kilo ohm, here the color code, now you can see here 220 kilo ohm initially, let's say it is 220 kilo ohm, then it is red, red, yellow, right? Now from kilo ohm, if I go to ohm, its color code get changed. I hope you are able to see, right? So initially let me keep it the 220 ohm. And what I will need to do now is I need to click here the start simulation. I want to show you the demonstrations of the Ohm's law, right? So I am clicking here on the start simulation. When I click there, friends, and let me toggle this switch, you can see the white color. I hope you are able to see this white color. So because we have kept the white color for the LED, it is unilluminated, right? I am making it off. I am making it white now. This is the try to watch this brightness. Try to watch this brightness. I wish all of you to focus on this brightness, right? Now what I'm doing again is I am doing a stop simulation, and now let me go to this resistor, and it was a 220 ohm, and now let me make it 220 kilo ohm. Let me make it 220 kilo ohm, and again I am doing a start simulation. Now according to the Ohm's law, what is I? I is equal to V upon R. So in the first hour experiment, my V was 3 volt and R was 220 ohm, right? So it's going to be 3 divided by 220. Now in this experiment, it is going to be I is equal to be 3 divided by 220 cross 10 raised to 3. That means the value of I is going to be decreased, right? So when you can see the value of I is decreased, when I toggle this switch, you can see the brightness. Can you visualize the difference in the brightness? Just try to remember this brightness, which is very close to gray. If I reduce the value of resistance, it becomes more white. Because the less current is passing through this LED, there is a less illumination to the white color, because we have set the LED color to white, so that you can visualize. Now again I stop it. You try to see, it is very near to the gray color. If I do the stop simulation, right, and again I go to the resistor, and let me make it a micro ohm, for example, 20 micro ohm, and then start a simulation. Now you can see the color. When I toggle the switch, you can see the color very white, right? Because I have resistor. Now see, important thing is, when I have make this resistance value very low, there is one warning coming to me here. You can see that warning. What that warning is saying, current through the LED is 61.9 milliampere. While, see, right now he is saying that the color which is passing through this LED is 61.9 milliampere, while the recommended maximum is 20 milliampere. 20 milliampere से ज़्यादा नहीं होना चाहिए. The usable lifetime of the LED may be reduced. If I continue like this with this resistance value, my LED will burn out very fast. That's what the warning I am getting, and that's from that understanding. If again I will change this resistance value, so I need to do the stop simulation. Again I will go to this resistor, and let me make it some reasonable, let's say ohm, and in that case you can see again I start the simulation. Now if I toggle this switch, you can see the illumination, and there is no warning, right? There is no warning. So this is how you can do an experiment with the Ohm's law. Now this is the ready-made circuit that I have taken. If I wish, I can take the battery, I can connect I can make a circuit like this. So let's do like this, right? So for example, I will do the stop simulation, and then let me do it again, right? And let me go to the basic components, right? So what I need is I need a resistor, right? Even I can do on the breadboard, but let's say I'm doing directly. So let me have this. What other things I need, friends? I need a battery. So let me take some battery, right? For example, let me take this 9-volt battery, for example, right? And let me get one push button or switch, right? So once I have that, let me have a switch of to terminal, so I can switch, slide switch, right? Or let me get this slide switch. Okay, which is ground and switch. So let me take this slide switch, right? So I got the slide switch here, and if you click on this, probably you can rotate also. So you know, I can rotate the switch. You can see on the left hand side the rotation is given, so I can put it like this, right? I can put it like this, the rotate switch, right? And now let me do the connection. So what I will do is, let's say I want to make a battery like this. I can rotate, right? And I can take it like this, right? And here this is the negative terminal of the battery, this is the positive terminal of the battery, right? So even still, if you wish, you can rotate like this, right? So this is your positive terminal and this is your negative terminal, right? So let's make the connection now. Suppose I want to connect, right? What I will do, for example, let me, this is the positive terminal, right? So positive terminal of this battery get connected to this switch. So you need to drag like this, right? This wire will come automatically and you have to click here, so it gets set, right? After doing that, I have to connect from here common terminal to this resistance, because resistor is unpolarized, so I can connect in any direction. And then this resistor, another terminal, get connected with the LED like this, because it's a anode, so I am connecting on the positive part, right? And then this negative terminal of the battery needs to be connected. See, this blue line will come, it represents this vertical, and then when you click here again, you will have a blue line. So you can take the straight path like this, and then again you need to click. When you click, you are getting a direction like this, and again when I click here, I am getting a direction like this, and this is how I can make the connection, right? So let me do that. So you can see the connection. Now what is remaining is one of the terminal again of this LED needs, this switch needs to be connected to the ground. So let me do this, right? And that's it, right? And or I hope it is not creating any kind of confusion. In that case, let me do like this, connect it with the negative. Yes, right. Now our circuit is ready. Let me check the value of the resistance. So it is 1 kilo ohm. Let me make it 2 kilo ohm, for example, and let me set this color to this time the maybe let's say green, if we can see, for example. Let me click on the start simulation, right? And let me toggle the switch. Can you see the green illumination, friends? Can you see this green illumination, right? You can see the green color. Now the LED is getting illuminated. Now let me do the stop simulation, and let's see what is the value of resistance. It was 2 kilo ohm, right? Let's make it 200 kilo ohm, for example. Then again the illumination has to be reduced. See, the current green shade, green illumination is get reduced, right? Because now try to remember this green color, which is very near to the dark, right? Brightness is reduced. If I reduce the value of the resistance, now you can see, if I reduce the value of resistance, let's say to 20 ohm, 20 ohm, for example, and let me run it, and now let me switch on and see the LED got away. Current through the LED is 252 milliampere, while absolute maximum is 20 milliampere. It gone. Can you see the star? It gone. because it is LED in the software, we can play around. Otherwise, if it's a real LED, it gone out, right? So this is how you can see. If I let me increase little bit the value of the resistance, rather than 20, let me make it 200 ohm, and because it is a 9 volt, let me make it 2000 ohm, right? And let's see, if I do like this, now you can see illumination is okay, right? So this is how you can make the basic circuits. Similarly, now what I expect all of you to do today in the homework is you should try to build a voltage divider circuit that we just now spoke about, right? My input was what, 5 volt, and then you try to measure the output voltage in the Tinkercad. For example, here you can also take the multimeter. So let me take this multimeter, so I can always do the search here, friends. I can write here the multimeter, right? And you can see here I'm getting a multimeter here, right? And so it has a positive, it has a negative terminal, and you can set the here what you want to measure, right? And where you want to measure. So for example, let's say I will connect this, let me take this multimeter here, and let me go like this, positive, sorry, let me do one thing. I have to put it appropriately so that I can run the cable, right? Let me rotate. Okay, fine. Now after doing this, here it is a positive, right? And because I'm using a laptop mouse, so it's working like this, but you can do it in better way. And then let me make it here. Right now what I will do is I will go to this and I will set the current ampere mode, and let me start the simulation. Let's see, ampere mode. Yes, you can even measure the, because it shows the 0, the reason is my ampere is in milliampere, and that's a reason. So I need to set that mode in the multimeter. Let me do that. But you can measure it, right? You can measure it, and you can take that variety. There is an option available. So similarly, you can do the voltage measurement also, right? For example, I can measure the voltage also. So what I have taught you today is, for example, if you want to do the V in and you take the V out, right? In that case you can do that. For example, let me again start simulation, toggle the switch. Yes, now you can see, hello, you can see 4.50 milliampere current, and the maximum rating is how much, 20 milliampere. Let me stop this simulation. Let me increase the reduce, let's say 200 ohm I'm making it, right? Now 200 ohm, and let me start simulation again and toggle the switch. You can see the green illumination, and you can see now what is the current passing through is the 44.7 milliampere, which is higher actually, right? When I make it off, you can see, and when I make it on, you can see the current passing through, right? 44.7 milliampere. And again, so if I make this resistance very low, probably what will happen is my LED goes off, right? So this is how you can measure. So you can measure the voltage, you can measure the current, you can measure the resistance also using multimeter. So whatever the concept we have discussed in this week, you can do all those experiments at your own on the Tinkercad.